Okay, so this is section 12.4. It's talking about the zeros of a function. But first, let's go ahead and recall something that we did back in chapter 3 when we were graphing. And we asked you to find the intercepts of an equation. So for example, here is an equation. And if I wanted you to find the intercept, the x-intercept, you remember you set the y to 0 and you solve for x. So we would set y to 0, and then we go ahead and we solve for x, and we find out that x equals 3. So the x-intercept then is 3, 0. That's where it crosses the x-axis. As you can see, I've graphed that point here. Then if we wanted to find the y-intercept, you would set the x to 0 and solve for y. So that's what I've done. I've set the x to 0, and I'm solving for y. And we find out that y equals a negative 12/5, or you can reduce that to a negative 2 2/5. So the y-intercept, where it crosses the y-axis, is at this point here, 0 at a negative 12/5. And that's why I put it as 2 1/2/5, because you can see that's more as 2 1/2/5. Now, what I've done here, some of you are probably wondering, but I'm counting these by 2. No, I guess I'm not. I'm sorry, that's in my other graph. All right. And so then you draw a straight line. Now remember, the graph of every linear equation is a straight line. How do you know this is a linear equation? Well, look at the original equation. The highest degree in any of the exponents is 1, right? So it's linear. So you know when you graph, you're always going to get a straight line. Now, let's take this same particular equation and solve for y. So I'm going to just manipulate it, and I solve for y. All right, so now it's the y equals mx plus b form. Do you remember that? Where m is the slope. You can also convert that then to a function notation by substituting in y this symbol, this notation is called the function of x. So when we're talking about functions, you're going to see that it's a function. And we talked about the different relations before, whereas some relations of x and y, there's a special relation that is called functions. Well, if it's already know it's a function, then they're going to, instead of saying y equals, they're going to go ahead and write this as a function to x, meaning that there's just one solution. Now we can set the function to 0 if we want to find the function of 0. And if we set that y equal to 0 or the function to 0 and we solve for x, which is what I'm doing here, that reveals the 0 of the function. All right, so what I did is I took the equation here and I set it equal to 0, and then I solved for x, and we got x equals 3. X equals 3 is what they call the 0 of function. The 0 of a function is a value of the independent variable that causes the function to equal 0. Therefore, to say the function has an x-intercept of 3, 0. In other words, remember we have x, y, right? They're saying that we solved and got x is 3 when y was 0, because that's what we really technically did here, right? Is we technically substituted in 0 for y. That's also x equals 0 is what we call the 0 of function. In the graph of the function, the 0 at x equals 3 has an x-intercept coordinate of 3, 0. So if you were to find the 0 of function and you find out that it's 3, then you're going to go ahead and graph then 3, 0 on your graph. That's where the 0 of the function is. Now note the word 0 now has two meanings. It represents the number 0, and in context with a function, it refers to the value of input variable that causes the function to be 0. So here in this example, it says find the zeros of the function. So the first thing you're going to do is you're going to set that function equal to 0. Then you're going to solve for the equation. We solve here because this happens to be, if you notice, the other one was a linear. This one here, the highest power is 2. So this is a quadratic equation, right? So we're going to factor both sides on the right. We're going to set each factor to 0. And we find out that x can equal 4 or x can equal -2. Now here we have two functions of 0. So the zeros, is what they would call them, the zeros is x equals -2 and 4. This does not mean that -2 equals 0 or that 4 equals 0. Rather, it means that the input values of -2 and 4 create an output of 0. So if I was to take the function and plug in a -2, I would end up with 0. And a 4, I would end up with 0. Let me just show you that. So here's our original equation. All right, I'm substituting in -2. And so -2 squared is 4. -2 times the -2 is +2. When we add 4, we get a +8, and 8 minus 8 is 0. So what they're just saying is when you plug in a -2, your y ends up being 0. Same thing if we plug in 4. What we find out is that our function then ends up solving to 0 when we plug that value in. All right, and so we get -2, 0, and 4, 0. So it's not -2 equals 0, it's the function of a -2 that equals 0. And notice we had then on the quadrant. All right, now we're going to take that same function, okay, and we're going to graph it. And we can begin by graphing it by plotting the two x-intercepts, right, which we found by finding the functions of 0, right? When we found the function, right, the function of zeros. And we did in the last thing we said was x equals a -2 and 4, right? That's how we came up with these coordinates. We can go ahead and graph that. We have -2, 0, and 4, 0. Which we've graphed. Now the graph is not a straight line because this function is quadratic, it's not linear. I mean linear, you have the 1 is the highest degree. Quadratic, 2 is the highest degree. If you look at this equation, we have 2 is the highest degree. So we're going to discover what shape do you get when you're graphing quadratic equations. The y-intercept is just an additional point that can be plotted. So if I wanted to say when x is 0, then what is y? So I'm just going to plug that into my original equation, plug in 0 for x, and I get a -8. So that's when you can then graph that, which I've graphed here down below. Now if you're wondering about my graph here, think of it this way. This is 2, 4, -2, -2, -4, -6, -8. All right, so 2, 4, 6, 8. So right here I have graphed 0, -8. And I don't know where that other point came from, but we'll see here. I think it just showed up early. To give the graph better shape, we're going to plot some other points by just plugging in some x values. And we're going to choose x values. Remember, you could randomly, when we were graphing before, you just would randomly put in numbers for x and solve for y and graph them. But we want to choose x values that are between a -2 and 4. So what numbers are between a 2 and 4. Well, -1 is between -2 and 4. 1 is between that. 2 is between that, and 3 is between that. So here are some random x values that I'm going to go ahead and solve for. So I'm going to take the first one and I'm going to plug in a -x into the function, and I end up getting a -1, -5, right? -1, -5. I'm going to go ahead and graph that. Plug in 1 into our function, right? And we end up with a -9. So I'm going to graph 1, -9. And then we're going to plug in 2, graph that, and we get 2, -8, which is already done. And then we're going to plug in 3, and we ended up with 3, -5. Now, as you can see here, we've got points that are kind of going, you know, across from each other here, right? See how they're going across, and there isn't any point that's going to go across this bigger one here at all right? Now, the graph of a quadratic function is called a parabola, all right? And so let me go ahead and connect these points if I can as nicely as I can. And you can see you end up with a graph like this. This is called a parabola. So quadratic equations, you're always going to end up with a parabola. And parabolas has a minimum point that's called the vertex, right? The minimum point is called the vertex. So this point right there, this last point at the very bottom where they both come together, that's that vertex, which is the 1, -9. That's called the vertex. The vertex is halfway between the two zeros. All right, so to find its x-coordinate, you just take the average of the two zeros. So what do I mean by it's halfway between my zeros, right? Well, remember, my 0 here is a -2 and a -4. So if I was to go divide this in half, right, between -2 and -4, and I go ahead and I draw a line down, notice that this vertex here is 1, -9. Well, let's see, is 1, if I was to take the average of the x-coordinates, right, the average of the zeros, let's see what happens. Take -2 plus 4, I get 2, and I end up getting 1. Well, that makes sense, right? If I take the average of the -2 and the 4, halfway between, I'm going to get the 1, which is my x value of my vertex. So now how do I find the y of my vertex? Well, you simply then will evaluate the function where the x value is 1, which I have done right here. Remember, I plugged in 1 and I ended up getting this value. So my x is 1 and my y is a -1, and this is the vertex. So that's how I found the vertex. Remember that. And when you get this graph, okay, that vertex, again, when I say it's that minimum point, it's where the slope of the parabola switches from a negative downward slope to a positive slope. So if you look here, this is going to a negative slope until we get to this vertex. This is our vertex. Then it starts going up at an upward slope. So we're calling that the vertex. It is the minimum. And also the parabola is symmetric, all right, which you can see that it's symmetric because we draw this line here that splits this. And so you can tell that this here is just a mirror image on the left that's on the right. It's symmetric. It's a symmetric figure. And so that's something that you would like to know about parabolas. Now it says graph the parabola using the zeros and the vertex. Now how do we know it's a parabola? They didn't even have to say parabola, right? We know it is because this is x is 2 at this particular point. The highest degree is 2. So, but they're telling you parabola, okay? Using the zeros and the vertex. So they're asking you to find the zeros and the vertex. So to find the zeros, right, I'm going to set the function equal to 0. Then I'm going to solve for x. I'm going to set each factor to 0. And I end up with x equals 1 or x equals 5. So that means my zeros then is 1, 5. Or I could graph 1, 0, 5, 0, which I'm graphing now. Okay, so I have found the zeros, and then it says graph also finding the vertex. You got to find the vertex. That's that minimum point. Well, how can I find the vertex? I can find it by taking the zeros. This is the zeros, and taking the average, and I end up with 3. So that tells me that 3 is going to be the x value of my coordinate. But to find the y now, I've got to plug in 3 for x to solve for y in my function. So when we solve that, we end up with 4. So that's telling me that the y is 4. And we're going to go ahead and plug that in. That is our vertex. And so we have our vertex 3, 4. Excuse me. So you really only need the 3 points for the parabola, for 3 points, but they have to be 1 point on the left side and 1 point on the right side. If I was to go ahead and draw my parabola, it's not the best. It looks more like a V than a U, but that's just kind of a general sketch of what my parabola would look like. Now, some parabolas might not cross the x-axis, okay? Like these cross to the x-axis right here and here, right? This is our x-axis. This occurs when the slope of the parabola changes from a positive to a negative or from a negative to positive before it reaches the x-axis. So such a parabola has no real zeros. For example, I could have a parabola that looks like this. What if this was the vertex? It doesn't cross. Or maybe my parabola might start here and go this way. But you see that these two parabolas, this parabola 1 and this parabola 2, is not crossing the x-axis like this parabola 3, okay? And we're going to talk a little bit more about that in our next section. But basically, they're going to ask you to find the zeros, find the vertex, and in some of your homework, they're going to actually ask you to go ahead then and to graph your parabola. All right? So those are the 3 things that you need to know how to do.